Hey everyone, this is lesson 513 on zero product property. So in this chapter we've been talking about quadratic equations, graphing them, representing them in different ways. And so our first goal is on this lesson is to see if we can take an equation and write it as a graph or represent it as a graph. Right? So this is only one component of all four of these things that we talked about on the previous lesson. And so not only are we trying to write the equation or show the equation as a graph, but we're also going to see if we could do this without a graphing calculator, because that would obviously be the easiest thing to do. And so we have to assume in this situation there is no graphing calculator available. So can we turn that equation into a graph? And so that was a question that came up last time. And so last lesson, this is a snapshot of what we did last lesson. We started with an equation and we plugged in some numbers, we created a table, and after plugging in all those numbers, we got their y values, and then we have a bunch of coordinates that we were able to plot, and then based off of the points, we're able to sketch a curve. So that is for sure one method of graphing a quadratic equation. That's definitely a method that works, and that's one approach that you need to know how to do. But we're going to see if we could go from this equation to the graph without having to do the table, without having to do all this work. And so that's what we're working towards on this lesson. And so what we're going to be looking at today is the zero product property, which we'll be using within our work. And so some things that we need to know. So specifically for this lesson, we need to know that x-intercepts always have y values equal to 0. So if you see a x-intercept, most likely it's going to look like 4, 0, 3, 0, or like -1, 0. Right? These are all x-intercepts, and I know they're all x-intercepts because these y values are all 0. Right? So y values equal to 0. Right? So if I ever ask you to write the x-intercepts, right away you know there's going to be 0 for the y value. And we're going to try to use that to help us. Since that's always true, when we set the quadratic function equal to 0 or equation equal to 0, that's what gives us this quadratic equation in standard form. And so I should probably write that. So this is what we call standard form. So you'll notice this is very familiar to us. We've seen this before. We've worked with quadratic expressions before. The only difference now is this is an equation that's equal to 0. Okay, so that's the only difference. So because this is familiar to us, we can start to use some tools that we've already been using. All right, so another thing to note is that when we solve an equation like this, when we solve this equation for x, those solutions have a special name, and we call them zeros. And the main reason is it kind of ties into the fact that we're setting it equal to 0, right? So zeros, when we solve, means solutions. And those solutions, or those zeros, is what's going to help us determine x-intercepts and vertex. And if you remember, those are key points in a quadratic graph or parabola. So those are key points on our graph. So if we know these, then that's going to help us graph, which is what it says here. All right, so the example I'm going to go through, I think most of this is worked out. So most of this you would probably just be copying as is. I'm going to try my best to explain the work I have here. And this is going to be pretty long. I think there's like 6 or 7 steps. And I'll just show you what all of that looks like. So this is a big picture of that. That's like a big picture of that. So there's a lot here. So I'm going to zoom in on the first couple points. All right, so this is, the first part should be pretty easy. So if I give you an equation like this, so if it says graph this equation, y equals x squared minus 6x plus 5, most people would either say, oh, that's fine, I'll use a graphing calculator. If not, you might say, like, how do I graph that? Like, what am I supposed to do? And so, like I said before, you could create a table of points and then use that table to graph it. So, which isn't too difficult, but a lot of people don't like to do the table. All right, so this is an alternative to that, which actually uses something that we're already familiar with. And so first thing is, let's write this as a quadratic equation, which means replace that y with a 0. So this y means we're going to plug in a 0 in place of it. So I've rewritten that here. So it should look the same, except I just moved the equals sign to the other side. And so this is what we're trying to solve. So we're going to try to use our algebra skills at this point. But like I mentioned before, we've seen this before. We've seen x squared minus 6x plus 5, this type of expression. And what we usually do with that is we factor. Right? So this is where all our factoring skills come in. All right, so I've already worked that out for us. And at some point, you're going to some of you might be able to do this without doing the area model and the x. It might be something easy enough where some of you could do this in your head. That's fine as well, unless I specifically ask you for to use a specific method. So, but for the most part, this is what we've been practicing, and so it just makes sense to use it. All right, so, and this is, I believe you will have a mastery test on this soon as well. So just to let you know. All right, so once we factor this, I've plugged in all my numbers, all this stuff comes from the equation. I've determined what numbers I can multiply to give me 5x squared. I plugged them in, and then I determined what was on the outside. All right, so I'm not going to go over that, but that's another lesson. So I'm assuming at this point you know how to factor, so that you understand what that means. And so the third part is actually what this lesson is focused on. And this is what we call the zero product property. And so once we factored it, right, so this is, this is what we call factored form. Right, so factored form. So what we're going to do is we're going to take our factored form of this equation, right? You'll notice it still has the equals 0 on it. You don't want to get rid of that. This is still an equation. But what we're going to do is use this property. And this property says, in order for this equation to be true, right, something times something equals to 0, one of these has to be equal to 0. All right, so you think about it. If you multiply two numbers and they equal to 0, so one of them has to be 0. Like 5 times 0 is 0. 100 times 0 is 0. So one of those numbers is always 0, or both of them are. So 0 times 0 is 0. So either both of these are 0 or one of these is 0. Since we don't know, what we need to do is you take each of these factors and really just split it up into two problems. And so the first one, you'll notice I put x minus 1. That's the first factor. And I'm going to set that one equal to 0. And the second one, x minus 5, I'm going to make that its own equation, x minus 5, and set it equal to 0. So now I have, instead of this complicated equation to solve, I split it into two simple equations, which should be easier to solve for us. So you'll notice if I add 1 to both sides, I get my answer, x equals to 1. If I add 5 to both sides, I get x equals to 5. All right, and that's it. So that's what the zero product property lets us do. And so what those numbers mean to us, right, since those are our solutions, that means, like if I ask you, well, what are the zeros of this equation? You could say, oh, the zeros are x equals to 1 and x equals to 5. Right? So if I ever ask you for the zeros, you would give me an answer like that. Right? The zeros are x equals to 1 and x equals to 5. Now, how does that help me? Well, it directly helps me find the x-intercepts. And so if I say, well, what are the x-intercepts of this equation or this graph? And you should say, oh, no problem. I already know my zeros, and so you should notice those are the same numbers that are part of your x-intercepts. So your x values are part of your x-intercept. So 1, 0, 1 comma 0, and 5 comma 0 are your x-intercepts. Right, so common mistake is to say, oh, my x-intercepts are 1 and 5. If you tell me they're 1 and 5, most likely I would say, well, that's not correct. Those are your zeros. X-intercepts, I want to see coordinates, right? And which means you also have to include these parentheses. If you don't put them, if you just put answers like 1 comma 0, I would mark that wrong. Right? So coordinates always have parentheses on them. All right. And so at this point, we have 2 points on our graph, which is now really we have enough to start our graph. And so this next part, let's see, this next part, what I've done is I've kind of sketched a little bit of a picture of the parabola here on the right side. And so I have the points 1 and 5, right? This is a sketch. This is not an accurate picture. My numbering might be a little bit off. All I know is that I have a 1 and a 5, and they cross the x-axis, right? Because these are x-intercepts. And so the question is, well, how do I know where maybe the vertex is, right? So how do I know the graph goes up and crosses like that, or how do I know that the graph doesn't go down, right? So the question is, where's my vertex? So if we could tell where the vertex is, then that's going to help us get a good idea of where this parabola is, and is it facing up or is it facing down? All right, and so the way we do this, one way is visually. So if you could draw the picture, I'm going to zoom into this. So if I plot these points, 0 and 5, one thing that I know is that because parabolas are symmetrical, right? Parabolas are symmetrical. They always have this line of symmetry, right? They always have this line of symmetry. And so and the vertex always goes through that line of symmetry, which means the vertex is always right in the middle. So you'll notice 1 and 5, if I go right in the middle, which is the number 3, right? So 1, 2, 3, 4, 5. 3 is right in the middle. That tells me where my vertex is. So one thing that I know for sure is that my vertex is going to be at 3. The x value is going to be at 3. What I need to figure out is what's the y value. And if I want to know that, all I have to do is plug in, let me color this differently, this 3. So I'm going to plug in a 3 into this equation. This is the original equation we started with. This is the original equation. All I'm going to do is plug it in. So usually, like when we do a table of points, we have to plug in like a lot of points. This is the only time where you would have to plug in a number. And so when we solve this, that gives us our y equals to -4. And so right away that tells me what my y value is. So vertex is equal to 3, -4 on this one. Let me highlight that. All right. And so again, the vertex is always in between the x-intercepts. And so the only time it wouldn't be in between is if for some reason the parabola is on the x-axis. In that case, your x-intercept is your vertex, right? But otherwise, it's going to be right in between. All right. All right. So that's at this point we have x-intercepts and we have a vertex. And so I've kind of already have a sketch of it, but here's a more official sketch of that. And so this would be, if our goal was to draw a picture, this is what it might look like. And this is a sketch. Doesn't have to be super accurate. In previous examples, I had like 5 or 7 points plotted. You'll notice I only have 3 points, the x-intercepts, and I have the vertex. So 3 points is all you need, and you could get a pretty good idea of where this parabola is. And so plot those points, and it definitely helps to label those points, and then the vertex as well. And then sketch a good picture of that as best as you can. I definitely, if you were off a bit, like if you were sketching this and you did something like this, I would probably mark that wrong. All right, so if you have key points, you better make sure you go through those key points. It doesn't make any sense not to. So be careful not to like go too short or do something like crooked like that. If it starts to come back, that's going to be something that's not okay. All right, so that's pretty much what we need to be able to do. Let me zoom back out to this. So this is the big picture of all that. Obviously, this looks a lot longer because I'm showing you a lot of details and notes and explaining it. But I'm going to do another example where I'm not going to write out all the steps to see it be a little bit shorter. And let's see if you can follow along with that. All right, so here's a new equation, and I'm trying to sketch a picture of y equals x squared plus 4x minus 5. All right, so first thing I'm going to do is I'm going to rewrite this. Let me zoom into this. So I'm going to rewrite this as x squared plus 4x minus 5 equals to 0. Right now it's in standard form. My goal is to factor this. So I'm going to put my box and maybe my x, and then I'm going to plug in everything to factor. This is a plus 4x, negative 5x squared, and I'm looking for two numbers. So this is going to be a positive 5x and a negative 1x should work. And so 5x, negative 1x. And then I'm looking for my factors on the outside would be x and x, negative 1 and positive 5. All right. So now what I have are my factors. So I'm going to rewrite this as, in factored form, x minus 1 times x plus 5 equals to 0. So there's my new equation. All I did right now is I wrote it in standard form to factored form. And so now this is where we get to use our zero product property. And so zero product property says I could do x minus 1 equals to 0. And I could split this to x plus 5 equals to 0. Two equations. And let's add 1 to both sides, minus 5 to both sides. I like to do both at the same time. And this is x equals to 1 and x equals to negative 5. All right, so these are my zeros. All right, so those are my zeros. And my x-intercepts would be 1, 0 and negative 5, 0. So those are there. I like to highlight them to let you know these are different answers. And so what I'm trying to figure out is maybe where the vertex is. And so if I'm not using a graph, you could plot these points and kind of get an idea of where the middle is. Another option for you to figure out your vertex is to take both of these. So if I take, let's see, 1 and negative 5, and I divide it by 2, which what this does is this gives us an average of these. And this number is, this is what, negative 4 over 2, which is equal to negative 2. What this tells me is my vertex is going to be at negative 2 comma something. All right, so let me see. So I need to figure out what that y value is. And so that's where that original equation comes back. And so what was that? That was going to be, I'm going to plug in that negative 2 into that equation. And so this is going to be y equals. So y equals to, this is going to be 4 minus 8 minus 5. So y is equal to, so this is going to be, I believe this is a negative 9. All right, so that means this is negative 9. All right, so now I have an idea of what my vertex is. And so I have enough points to kind of sketch this. And let's see. So negative 2, negative 9. So let me, all right, so this is going to be a sketch, meaning I'm not going to necessarily count. All I know is I have a negative number, and I'm just going to call this negative 5. And I have a positive 1, and I'm just going to call this positive 1. Right. All right, so in this case, I'm just kind of ignoring these boxes. And I have negative 2, negative 9. So negative 2 is going to be somewhere in the middle. Right? Well, for sure it's going to be somewhere in the middle. And negative 9 is going to be somewhere down here. Right? So all I'm going to do is I'm going to kind of pick a point that's pretty low, and I'm going to call this negative 2, negative 9, which is our vertex. And I'm going to sketch a picture of this. So what this does is it gives us an idea of where this graph is. This is what we just call a sketch. Right? Sketched, it doesn't have to be super accurate, but it should have these points, right? These are this is your x-intercepts, which was 1, 0, and this is your other x-intercept, which was negative 5, 0. Right? So those 3 points give us a good idea of where that graph is. All right. So that's kind of what you need to be able to do. You'll notice the work is, I pretty much did this like in half a page instead of like a page and a half before. So that's what you need to be able, need to know how to do. And so the main part, really what we were focused on today, was using our factoring and using the zero product property. All right, so that was the key part today, and that's what the zero product property is. It's really just this part right here, is you taking your factors and setting them equal to 0. Right, that is your zero product property. So if I give you a specific question and I say use the zero product property, means I need you to factor and set them equal to 0 and solve, which means you're going to find your zeros. All right, and all that will help you graph. All right, that's it for this video. Let me know if you have any questions or if you want some additional problems to practice. The next few lessons will have some more practice of this when we move forward. All right, thank you.